that I'm not purporting to be able to calculate the exact surface temperature of the Earth or Venus, for that matter, by using the pressure of the atmosphere alone or total solar radiance. Because if you try to do that, and people have, Donald Huffman has tried this, and you arrive at a number that's a little bit hotter than Earth's actual 13.9 Celsius average surface temperature. And you can try other clever ways, like just using the ideal gas law and try to calculate, okay, what would be the sort of constant steady-state temperature of a body of gas under a pressure of 1 atmosphere, and it's not enough to account for the temperature that we see. But one thing that can be said is that I think it's very erroneous to calculate the temperature of the Earth based on an albedo. I think pretty much all of the sun's energy is being is being imparted to these stellar bodies, and because if you look at much of the sun's energy is being delivered in the infrared spectrum, so it's going to be absorbed by gases, and so water vapor for that matter. So there's, and of course there's a big difference between Earth and Venus. Earth has a liquid surface, Venus has a rock surface. This matter has different properties. So, but what can be said is that the radiative forcing hypothesis, or the perpetual recycling of heat from trapping gases, right, via back radiation or radiative forcing, right? This mechanism is non-physical, right? That's one thing we can say with a high degree of certainty. It violates the conservation of energy, because you can't ever amplify an energy flux value. So if you have a laser that's producing, and remember, power and energy are not the same thing. Power is the rate at which work is done. Energy can be seen as a cumulative value of work performed over a given period of time. So it's the sum of power. It's energy would be 1 kilowatt done over 1 hour. But you can arrive. Power is power in a way is a constant measurement of a delivery of energy, whereas energy is a cumulative sum of that energy delivery. So the problem with the greenhouse effect is that it effectively states that you can take a laser and you can beam that laser at, say, a cube of black metal with the very high emissivity or absorptivity. Let's say 0.95. So it'll absorb 95% of all the incident radiation from the laser, and so you'll get a temperature. You'll get a temperature equal to the radiative flux per square meter, whatever, right? So if you have a 100-watt laser and you're beaming that 100 watts over a 1 square centimeter cube, the cube will reach a steady-state temperature exactly proportional to the amount of energy delivered, regardless of how you insulate the cube or how you or the rate at which the cube can lose heat to its surroundings, right? This is a fundamental fallacy, right? If you blanket that cube with aluminum foil that has an emissivity of 0.05 and reflect most of the infrared back to the cube, there'll be no rise in temperature, right? Because to raise the temperature of that cube, you need to increase the steady state flow of energy to the cube, right? Because if you argue that you can raise the temperature of the cube by altering the amount of energy that leaves the cube, what you're effectively saying is that you can build up energy, and that does not happen, right? You can't. People look at energy or power or energy flux, I should say, as this sort of like water flowing down a pipe or gas flowing through a pipe, where you can apply a constriction to the pipe effectively, right? You're slowing down the rate at which gas or water is exiting the pipe, and so there's a greater density, right, of water or gas just behind the constriction. And the idea is that kind of we're in that constriction zone, right? The atmosphere is that constriction zone, so there's a constant value of energy coming in, but we're altering the amount of energy leaving, so that energy can build up. But that does not happen. That's not physical, because you create a work from nothing. You can never increase the power density of an energy flux unless you either change the energy flux or the area at which you project that energy flux, right? So you can change the power density. That we can do. You can shrink the Earth, and the Earth will heat. But then again, you can't really do that because you have to have a mirror, because if you shrink the Earth absorbs less radiation. So the only way to warm the Earth without changing solar flux would be to have a massive mirror, the size of the existing Earth, let's say. But then you shrink the Earth, right? And you beam that mirror over a smaller Earth, and of course the smaller Earth has less heat capacity. So a given flux of energy will raise it to a higher temperature. So you cannot heat the Earth by bottling up energy like this. This idea that we can bottle up energy is unphysical, because if you could do that, again, you could take that laser and you could set it at a very low power setting and just bottle up all the energy the laser produces and achieve a higher steady state temperature in that cube, the heated cube. That of course never happens, because you create a work from nothing. So the origin of the confusion is actually the conflation of slowing the rate of cooling and the production of energy. Those are two different things. You can never increase the total available energy by bottling it up like that. It's quite surprising that people like Samantha Arrhenius or Tyndall or Fourier actually were confused about it. And to be honest, it took me I was 21 when I discovered the greenhouse effect was a fraud, and that was quite startling. And but initially I had a hard time believing it. It's not possible that everybody is wrong, but actually, of course it is, right? Because there's been numerous history of science is a process of continuous improvement, right? So by definition, improvement presupposes that any given time, right, anything you have is deficient, right? Because otherwise it couldn't be improved. So everything we have is because there are a number of wrong theories that were disposed of. This is one of them. So the accumulation of knowledge involves a rejection of stuff that just isn't veracious, and this is one of them.